What's up, YouTubers? Jose Quiñones, the CNC Dude, here with my dead Hobart Handler 140 MIG Welder. It is a gunner. It is not welding anymore. It's more like sputtering and doing some nasty business. So it has become out of commission. Now, I don't have anything negative to say about this machine. It lasted 20 years, which is a lot. So, I mean, 20 years, come on, it's just basically did what it was supposed to do and probably more. So nothing wrong with the machine on a per design point of view, but unfortunately it doesn't work. Everything breaks and at some point dies, so it's time. The question is, can we bring it back to life without needing to dig a 6-foot hole to put it in? I think we can. So I went inside, looked into what might be the problem, and I think I know what the problem is as well as the solution. So let's take a look at how this puppy works and learn a few things about how MIG Welder transformer-based machines operate, and in this case, what is wrong and what will be the solution. At the end, I'm going to have a question I am hoping some of you guys can help me with. Actually, I thought before we go in, let me give you a background of how I discovered the welder had kicked the bucket. I'm going to show you some welds in here. Some of them are exactly what you would expect for a welding to be. And then this is the kind of welding I was getting from the welder towards its end. I started welding a few weeks ago when the weather got better, and at first the machine was kind of working and going in and out from working and sputtering. I felt like it wasn't welding perfectly well, but it was at least welding, so in my mind there was no problem. And then all of a sudden it started, it just basically gave up, and everything was the worst possible welds you will ever see. So of course, being a guy who loves to troubleshoot issues, I started to wonder what could be the problem. At first I thought maybe the gas had stopped working, so I checked the gas. No, there was gas, so that was not it. I then moved into maybe there is a problem with the nozzle, right? So I changed everything here. I changed literally every single component in the nozzle. I started thinking maybe it's a problem with speed, maybe it's a problem with voltage. No setting would make it work. So it wasn't the gas, it wasn't the nozzle, it wasn't, the motor was working. I mean, obviously it was pushing wire out. So every single aspect of the things that are undergoing when you're welding metal were not working. The only thing missing was the internal circuitry. So maybe I thought there was a blown FET, something that I could probably repair, or something was not working as it should. And of course, at that point in time, it was obvious that I had to open it up and start working with it. I do not recommend anybody working with high voltage unless you have been trained to do so. I have been trained with high voltage. That's why I allow myself to look into high voltage stuff. I will tell you, first thing is make sure you disconnect your machine from the line power to make sure that there is no way of you getting shocked. Inside of the machine, there is a big transformer, so there could be some residual energy. Be mindful of that. There is also a big cap. However, the cap is at the output, so that would have low voltage. Still, be careful with it. You're probably not going to get shocked with 28 volts, but better not to risk it. Once you go inside, you are at your own risk, so make sure that you know what you're doing or work with somebody that knows what they're doing, because this could result in a lethal incursion. So my recommendation is, unless you know what you're doing, don't go in there. All right, so let's see what we have in here. Again, remember to only go in here when there is no power. The transformer could have residual power. The cap will definitely have some residual power. And although it is hard to get chucked with the cap, you just don't want to be the guy who happens to get chucked, okay? So here's the board. There is only 2 relays, a Darlington pair, which I believe is used to drive the motor. As you can see here, the 2 connectors for the motor, the 2 wire connector for the motor. So my impression is this guy is used to drive the motor that fits the wire. You don't need a whole bunch of circuitry because the motor is just moving. It's basically just getting pushed out. So the only thing that does happen is that we control the speed with the potentiometer in the front. So they're probably changing the gain on the differential on the Darlington pair, and that causes the wire to change speeds. Then we have a connector where pretty much everything else goes in here. These are 2 relays. There is a differential amplifier in here, which I'm not sure what it's doing, probably sensing the voltage and closing the loop somehow. I'm not sure how that happens, because my impression is that everything happens from the transformer through a rectifier in here, or actually here, and then into the cap, which goes into the output. But before I go there, let me say that I did read online that these relays sometimes go bad. In my case, I tested them by driving the relay element, basically the electromagnet, and they both switch. So I was able to get the normally open and the normally closed contacts to work as intended. So that tells me that the relays are good. Now, if the relays had been busted, that would have been a problem, because these relays are pretty much obsolete. So pretty much everything else, just diodes, caps, resistors, and a transistor here. So I'm not sure exactly what all of this is doing, but probably it's just a matter of, opening. Here's the valve for the gas, so that is probably a little bit of a driver for that to enable this only when you are pushing the wire and welding. This is a transformer. This transformer takes the 120 volts AC, rectifies to 24 volts DC to generate the power for all of this and driving the motor and so on. So this obviously has to be working because I have the operation of the system, the motor is being driven, and everything else works. So that tells me the 24 volts are present. And in fact, that should be pretty simple to measure. I didn't do it because it's pretty obvious that it's working. Otherwise, you wouldn't even get the wire being fed. So everything here appears to be working. I couldn't find anything that was broken. This leads me to believe, let me pull the camera to the top so you can see what the heck I'm talking about next. All right, so what the heck are we looking at here? So these are the 2 elements that are the secondary on the transformer that has been chosen by the voltage selector. And remember, there are 4 possible options. They go into rectifier diodes. So that tells me that depending on which output you have chosen, the AC voltage, the step-down AC voltage, is going to get rectified. So as you can see, this gigantor plate of aluminum goes down here into one side of the cap. And if I recall, that was either, I don't remember if that was the positive or the negative. So the other side of the transformer goes into the other side of the cap. So the rectified output is going to charge up this cap. The cap then pushes current through this choke in here into the MIG gun. So because everything here is working and I was able to measure a voltage when the gun was basically when I didn't have a wire, I was able to measure a DC voltage. But now measuring the voltage output is tricky because there is one thing as measuring the voltage when you are not welding and then measuring the voltage when you are welding. So obviously measuring the voltage when you're welding is practically, I mean, I don't even know how you would do that because you're literally melting metal as you're welding. So that's going to be really hard to measure. But when you are not welding, in other words, there is no wire getting molten, you can measure the DC voltage output of the transformer. So to do that, let me show you how I remove the wire from the machine. This is you see this cable here, this is the DC motor. Disconnect this guy. This is a Molex connector. I have a bunch of these, so I have been using this connector for so long. I have my own harness, but you can also use clips or something to attach to these wires. And now I'm going to route this to my power supply. And because it's a variable power supply, let me show you. I'm going to connect to plus and minus. Now, which one is plus and minus? So obviously, if I connect this guy and the wire starts to push out, all I have to do is reverse it. Turn power supply on. Right now, voltage is 0, so I'm going to start increasing it. So obviously, make sure that you trim that little ball or the wire will not have anywhere to go. There we go. You're going to have to do the hand wrapping manually. And now we have recovered our wire. Because I'm a cheap bastard and I don't want to cut it. So once you have removed the wire from the machine, you can now measure the voltage with having wire going out. Remember, for this to work, you cannot be on purge, because on purge, you don't have a transformer output. You have to be on one of the transformer outputs. And that would cause the machine to push wire out, so that would be a mess. So remove the wire, and then measure the voltage with a voltmeter. And when I did that, I was able to see that in fact we have 28 volts on the transformer output, which tells me that we have enough voltage. However, remember what I told you, there is a big difference between measuring the voltage when you are not welding than when you are welding. So my suspicion is that the transformer is working, the choke is working, and the cap would be working, except that I don't think it is. My impression is that the cap has lost its ability to keep the voltage as high as it needs to be during the welding operation. Everything points out to the system working perfectly well, except that for whatever reason, I do not have the ability to sustain the voltage. That points out to the cap not doing what it's supposed to do. By the way, this is an electrolytic cap. By definitions, electrolytic caps have a finite life. The electrolytic inside just decays, it evaporates, or it gets dried up, whatever it is, whatever mechanism happens, an electrolytic cap is not going to last forever. So at some point in time, they're just going to die out. Everything points to that. If it had been the transformer, I would have been able to see that the voltage was not what it was in open loop, or I mean when it is not welding. But the voltage was there. It is just that the cap is not able to sustain it, which is something you would expect when the capacitance of the cap is no longer what it's supposed to be. So the solution to fix this problem is to get a new cap. Now, I thought I was just going to be able to go online, to go to one of the places where you buy electronic components like DigiKey or Mouser and find a similar cap, but to no luck, there was no such a thing. I believe this is a cap that was probably designed exclusively for Miller or Hobart welders, So good luck finding a cap of 53,000 microfarads minus 10% plus 75%, 35 volts DC, 50 volts surge. And it must be this diameter and have two screws at the same distance because the bus wires inside are too large. So my impression is that you will need to buy this directly from Miller or Hobart, and they are $130 a pop. And I'm gonna be honest with you, I would buy the cap for $130 if I was 100% convinced, but I don't know. This is just a hypothesis at this point in time, so I will need to validate it somehow. And you know, if one of you, this is the question that I have for the group, if one of you know where I can find this cap for something like $50, please let me know. It has to be a brand new cap. It cannot be a 20-year-old cap because a 20-year-old cap is not going to fly. Remember, these things degrade with time. So if there is a way to find a similar cap for like $50 or less, let me know. I will be interested in buying one just to see if in fact that is the problem. Well, YouTubers, in the event that I find this capacitor for less than $50, I promise to bring this machine back into its former glory. But in the meantime, I have a lot of projects that I want to work on, so I decided to pick this puppy up, an Orc Captain MIG 200 out of Amazon. I'll leave an associate's link in case you're interested in trying this yourself. I am going to do another video on this machine because this video is already too long, but I will advance that I'm incredibly happy with the results this machine has provided. It is a MIG machine, but it can do arc welding, it can do TIG, and it can even do a spool gun. So I'm actually interested in doing that. I don't have those gadgets yet, but I'll see if I can acquire them in the near future. It is an inverter design, so I'm not even sure it is going to last 20 years, but let's be honest, I'm not even sure I'm going to be here in 20 years. So maybe it outlives me. I have no idea. I cannot see the future. I wish I could. So far, so good, but if it's going to last 20 years or not, I have no idea. The Hobart did, this one, I'm not sure. But here, listen, maybe AI takes over in a few years and they just decide that I am not, I'm just too old, a dinosaur, so they just send me to become cookies or something. So I am not even sure if I'm going to be here in 20 years. I'm not even sure if this machine is going to be here in 20 years. All I can tell you is that right now it's working beautifully, and I'm super happy to have acquired it. But remember, in the event that you can help me find this cap for less than $50, please put it in the comments. I'm looking forward to resurrecting the Hobart 140 MIG handler. In the meantime, if you have stayed this long having this wonderful discussion with me about MIG welders and how to repair them, I want to thank you for tuning into my YouTube channel, and I'll be seeing you on the next one.